Hey, Mr. Mutford here. We're going to assume this nasty quadratic can actually be factored by inspection, but we're going to have to do some interesting hoops. So we think we can find a binomial times a binomial where row times column produces these four values, and two of these are going to collapse because they're like terms into that trinomial. But again, I bring it back to the multiplication box so you can see 1, 2, 3, 4 things. 4 things, quadratics, that's why we call them that. Here we go. So we know the x term and the x term are going to produce the 48 x squared, and the number term and the number term are going to produce the negative 15. I had them pop in the wrong order, no big deal. But we don't know how to split these two things up. So take this original quadratic, and we're going to do a swing method, where whatever that coefficient is divided here, and then multiplied to whatever that is, and it produces a new swing quadratic, not the original, but it's a 1x squared. And now we can just go right after the factors here again, assuming this is going to factor nicely. So we continue with our setup, which I call halvesies. The two things have to add up to the negative 22. So we're going to take half and then the other half to add up to negative 22. And then their product is going to equal that negative 720. So no guess and check at all. It's just half of negative 22 plus a bit, the other half minus a bit, and they multiply up to this. So let's actually multiply them. Difference of perfect squares pops right out here. And we're just going to solve this by moving two terms. We get 841 is b squared, so square root. You should always think positive or negative, but it doesn't matter because when you plug them in here, you're going to get both cases regardless. So b is 29, which gives us the top halvesy is 18. The bottom halvesy is negative 40. And that immediately tells us 18x and negative 40x over here. This process was to get you the two things you needed to add up to the negative 22, but no guesswork was involved. You went straight for it with the halvesies method. So now we're going to get a greatest common factor on one row or one column. Doesn't matter which way you start. I started with a row because I saw negatives and multiples of 5, so we went here, but you're going to want to alternate in case back here on the original you forgot to distribute anything out. We can't for this one, but in case you have a different one, you're going to want to alternate here. So that negative 5 times that 3 makes this box happy, so I gave it a dot. Now that I have a column, let's go for the other row. 3 times 6x makes that box happy. Well, 6x times 8x makes that box happy. And for good measure, check the last box. It all works out. So we get the factors. These label is one factor. These labels are the other factor. It's still equal to 0. And we can now solve both halves. And it's done. All right, thanks for listening. I hope this was helpful. Again, it's a video. Play it as many times as you need. Keep going back until things click. Thanks for listening.